So let's just practice using this notation, okay, and make sure that we are able to apply this notation properly and resolve these as well. So we're going from 1 to infinity. Okay, so I'm just going to sketch this graph. Okay, the graph of this looks like this. It's a 1 over x squared function, and we're going to start at 1, and we're going to look at this area all the way out to infinity. Okay, so we can't have infinity as a bound. Okay, so we're going to write this with a limit. So we're going to say the limit as a goes to infinity from 1 to a of 1 over x squared dx. Okay, so then we go limit a to infinity. This becomes negative 1 over x from 1 to a. Okay, so this area inside here we can then just plug in. We're going to end up with negative 1 over, well, a is infinite, so we're going to go 1 over infinity minus negative 1 over 1. This area works out to be 1 unit squared. Okay, so the area from 1 to infinity under the 1 over x squared function, the area is 1, which is interesting because this area, which isn't all that much different, this area is infinite. But if you look more closely at the graphs, this one dives down because of the strength of the power in the denominator. This one dives down to 0 fast enough for it to have finite area. Okay, so it is the denominator. If you compare the two graphs, you'll see that this one goes much quicker to 0 compared to the 1 over x function. The 1 over x function kind of goes like this and kind of hovers above 0, whereas this one dives down to 0. Okay, so that's why that has finite area. Now, and we're not going to necessarily do it right now, but I think I alluded to this, is that if this one side is infinite or finite, so in this case it's finite, this side happens to be infinite. Okay, and we'll look at some of these examples later. Okay, so here we have, again, this is a vertical asymptote at that point. So just sketching the graph, okay, it's going to be a vertical asymptote there. It's going to look more like this. And then we're going from 0 to 2. And actually this one has values to find the negative region, so it's like this. So we're looking for the area from 0 to 2. So we are looking at the unbounded region on the right-hand side of 0. Okay, so then we need to use a limit. So we need to use a limit here, limit as a goes to 0, and we're doing it from the positive side, okay, right? Because we're going from the positive side here. And we want the integral from a to 2 of 1 over the 5th root of x. Okay, using the power rule, I'm going to anti-differentiate this. Okay, so I'm going to end up with x to the power 4/5 divided by 4/5 from a to 2. Okay, cleaning this up a little bit, it's going to look like this. Limit as a goes to 0 from the positive side of 5 over 4 and x to the 4/5 from a to 2. Okay, this is going to be 5 over 4. We're going to plug 2 in there, so it's going to be the 2 to the 4/5 minus 0 to the 4/5, or 0. So our answer looks like this. 5 over 4, 2 to the 4/5. And that would be the area inside here. And that would be a finite area. Okay, this area happens to be finite. That is along the vertical asymptote. This one here, we'll look at the same thing. This one has a domain restriction. Okay, so it has a domain restriction at x equals 3. So integrating from 0, well, there's nothing on this side here. So really it's just going to be like that. It's from 0 to negative infinity. Oops, so it's going to go the other way. So horizontal, it's going to go like that. Okay. And on the right hand side here, there's nothing exists. And we want from 0 to negative infinity. So we're going to take this area in here. Okay, so there's two unbounded areas, but we're looking for the unbounded area along the horizontal. So looking at that, we're going to say limit as a approaches negative infinity of 1 over square root 3 minus x dx from a to 0. Okay, so limit as a goes to negative infinity, we anti-differentiate this. So this is going to be 2 square root 3 minus x, and then make sure we times that by the negative 1 because of the coefficient in there. And then we'll have our bounds from a to 0. Okay, so then we can plug in. So I'm just going to put it here, negative 2, and then we're going to plug in our 0, so it's going to be cube root of 3 minus the cube root of 3 minus negative infinity, which is infinity. Okay, so we end up with negative infinity times negative 2, so that's just going to equal positive infinity. So that area, unbounded area, happens to be infinite.